draw the following 5-bit registers. So 5-bit register means you have 5 flip-flops. Each flip-flop is a bit. So usually it's a D flip-flop. I think we saw one earlier where it was a T. Okay. Okay, so part A here is easy. It says can rotate right by 1 bit. That is bits 4, 3, Q4, Q3, Q2, Q1, Q0, rotate right to Q0, Q4, Q3, Q2, Q1. Now, that sometimes gets people a little confused if it's the first time they've seen it on the test, but just remember, he likes numbering 4, 3, 2, 1, 0, and if you do it that way, rotating right by 1 bit means you're going to the right. And so the output of 4 goes to 3, 3 goes to 2, 2 goes to 1, 1 goes to 0, and then 0 is going to go back to 4. And that's all there is to that one. Okay, now the next one is a little harder.
Would you draw it the same if it was the normal 4, 3, 2, 1, 0? Like, what would be different if you didn't shift it at all? Like, how would you draw the 5? I know you draw the steps, but how would you draw the line?
Well, there wouldn't be a wire. I mean that's just this is a shift register, yeah. So the wire is what makes it a shift register. Yep. So I don't have to connect them that way. Let's see if I can be any neater this time. And there is a clock. I didn't put the clock in. You can always put the clock in. And that's always a good thing to do on the test if you're stalling when you're trying to figure out, I don't know what to do next. Well, always draw the clock. Okay, so this is 4, 3, 2, 1, 0. A register that can rotate right by 2 bits, that is Q4, Q3, Q2, Q1, Q0, rotate right to Q1, Q0, Q4, Q3, Q2 when input purple equals 0, or rotate right by 1 bit when purple equals 1. So that's an if. That's an if right there. It's telling you do this in one case and do this in another case, which tells you we're going to have a multiplexer on each of these. And I'm going to put my S on top this time. So I have purple is my variable. Zero, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay, so rotate right 2 bits when input purple equals 0. So that means I'm going to go into the 0. Oh, also, all of these multiplexers connect to the D input of their flip-flop. So I'm going to rotate right 2 bits. So this 4 is going to go into the 0 for the 2. The 3 is going to go to the 1, and it's going to the 0 because this is supposed to be what happens when purple is 0. The 2 goes to the 0. The 1 has to go back around and go to the 4. And the 0 has to go back around and go to the 3. So each one just went over 2 and went into the 0 input of the multiplexer because it said when purple equals 0. Or rotate right by 1 bit when purple equals 1. So if purple equals 1, you're just going to go to the right by 1 bit. So I'm going to go from 4 right there. From each output, I'm going to go to the 1 of the register directly to the right, and then the last one goes back around to the beginning. Okay, I only have time to do